problem is this: prove that if the vector is the gradient of a scalar function, if the vector is the gradient of a is the gradient of a scalar function, vector is the gradient of a scalar function, then its line integral around a closed path is 0. Its line integral along a closed path is 0. Vector is a gradient of a scalar function. Let f is a given vector. It is equal to the gradient of a scalar function. It is a vector and it is equal to the gradient of a scalar function. So line integral or f. So its line integral around a closed curve is 0. Line integral of f dot dr. So f is equal to the gradient of a scalar function, and putting this value gradient and dr, I multiply I, j multiply j, k multiply k. So this is the line integral of a to b partial over partial x phi dx dz, and line integral of f is equal to d into phi, d into phi. So taking the derivative, we will get d phi, d phi and d phi. Derivative 1 1 1 d phi. Line integral of a function f is equal to from a to b is equal to d phi 1 2 and 3 d phi. So line integral of a function is equal to d phi is equal to phi b change into a. For closed path, put a is equal to b. A is equal to b. We get a is equal to b. Putting the first of our upper limit, lower. It's the upper limit, lower limit, upper limit into lower limit, and we will get 0. So if the vector is a gradient, if the vector is the gradient of a scalar function, then prove that its line integral of a closed surface is equal to 0. So first of all, this is the given condition. We are taking the line integral of f from a to b, gradient phi r f into dr, f into dr. First of all, we will write f is equal to dr, f is equal to gradient phi and dr. Gradient phi is equal to partial xi, partial over partial yj, partial over partial zk into dx, dxi, dyj and dzk from a to b, partial over partial x x d phi. Here also d phi d phi from a to b. So we get d phi common. We get d phi common from a to b, putting upper limit minus lower limit, putting a is equal to b, b is equal to a, 0. So it is proved that line integral of function f is equal to